So today we are going to do Unit 2, Lesson 5, which is a continuation of the angle theorems that we started talking about yesterday. So starting with these first three, let me let somebody in. Starting with the three blue ones, okay? So vertical angles are going to be directly across from each other. So you can see the A here and the B here. Vertical angles are congruent, meaning that they are the same measure. Whenever we name angles in a form like this, we need to use the vertex as the center, kind of like if we were doing a triangle, okay? So when two lines intersect, the vertex is in the center, and that's the center of all the names of each of the angles. And then the transitive property is a property that you learned in Math 1, and it says that if A equals B and B equals C, then A should also equal C, okay? So let's go down to the bottom of our paper, and all these three in blue, and a linear pair. Linear pairs are adjacent angles. Remember, adjacent means that they're right beside each other, and they are formed by two intersecting lines, okay? A linear pair equals, so let me add this, equals 180 degrees if you add the two angles together. They are a linear pair, meaning that they're supplementary. So I'm going to come down to the bottom, and I'm going to do this very colorful example first, okay? And we're going to identify the names of each of these angles, okay? And you'll want to be sure to add the letters. So P, T, Q is going to be the name of this blue region. P, T, Q. Okay. The green region will be Q, T, R. Q, T, R. The yellow region will be RTS, and the pink region will be STP. STP. Now, yes, technically you can go backwards. You could have said PTS as long as the T is in the middle. And let me try to make this darker for you. As long as the T is in the middle, then you're okay. Okay, so I'm going to use my highlighters today to help us look at these different vocabulary terms. So I've got a little blue dot next to these corresponding with the little blue dot that's up above. So let's see, transitive property, linear pair, vertical angles, and then we spoke about already naming them using the vertex. So that's all four of the blue dots. All right, so the vertical angles are the ones that are directly across from one another. So pink and green are directly across from one another. So pink and green. These are a set of vertical angles. Vertical angles, remember, are congruent to one another. So pink and green are congruent. Also, blue and yellow are congruent. So I'm going to put and blue and yellow. I'm hoping that these colors will help us kind of see it a little faster. You can also take the angle names, okay, RTS and PTQ. That is the name of the blue angle and the name of the yellow angle. Okay, or STP is pink. And QTR was green. Okay. Alrighty. So those are our vertical angles. Let's identify our linear pairs. Okay. Linear pairs are angles that are adjacent to one another. So they're right next to each other. So one linear pair would be blue and green. Okay, blue and green are linear. Blue and green. Also, blue and pink form a linear pair. Blue and pink. Also, pink and yellow form a linear pair. Pink and yellow. And then the last linear pair is I went all the way in the circle. So yellow and green form a linear pair. So I have 4 linear pairs here. And these highlighters are just a way to help me identify it visually. So and. That's my and symbol. So we have 4 sets of linear pairs. Okay. Now let's talk about the transitive property. The transitive property. So the transitive property is going to put together the definition of linear pair and kind of prove vertical angles, okay? All at the same time. So here's what the transitive property says. It says if blue and green are congruent to one another, I'm sorry, blue and green, if you add those angles and they equal 180, okay? And make sure I write this the same way I'm used to writing it. Okay, so blue plus green equals 180, because that's the definition of the linear pair. And so if blue plus green equals 180 and blue plus pink equals 180, get my right colors. Blue plus pink equals 180. Then pink and green must be congruent to one another. Congruent. All right? They must be congruent. I'm hoping that this with the colors helps it to make some kind of sense. Okay. Let's talk about the other vocabulary terms. Scooch this up a tiny bit. Okay. So this is going to get a little bit messy, but it's okay. What I have here is the black dot from number 4 up above. The black dot is next to the word parallel. So I just wanted to write down here, this is how they will tell you line R is parallel to line S. And if you look at the image, they'll put these little arrows, and that's how you'll know by looking that they're parallel. Okay. In red up here, next to that, I put a, or next to number 8, which is transversal, I put a red dot. And I put a red dot there because this red line, they call it line T, but line T is a transversal. A transversal is a line that cuts 2 other lines or slices them, either way. You can slice an apple or you can cut an apple. Same thing. Okay. And so with this set of parallel lines that is cut by a transversal, I end up with all these different theorems. I have corresponding angles. Corresponding angles are angles that are in the same place. Corresponding is number 6. They're angles on the same side of the transversal. So I'm on the right-hand side of this transversal right here. They're on the same side of the transversal and in the same position on the parallel lines. So let's identify some corresponding angles on this side, okay? So 2 is on the top right and 6 is on the top right. So that means angle 2 is congruent to angle 6. Angle 2 is congruent to angle 6 by corresponding angles.
I need a pencil.
Okay, also angle 4 is on the bottom right, angle 8 is on the bottom right. So these angles will be congruent as well. So angle 4 is congruent to angle 8. So I want you to look at the left side of the transversal and see if you can identify the other 2 corresponding angles in this figure. And I know that this is tight space here. Okay, so I found angle 1 is corresponding to angle 5. And angle 3 is corresponding to angle 7. So corresponding angles are congruent. Okay. Let's look at same side interior angles. Same side interior angles. So same side interior angles, this is the bottom vocab here. It is on the same side of the transversal, so still on the same side, but they are in between the parallel lines. So angle 4 and angle 6 are on the insides, okay? And so they are going to be supplementary to one another. So here's how I write that. Angle 4 plus angle 6 equals 180 degrees. 180 degrees. There is one other set of same side interior angles here. Okay. and that is 3 and 5. 3 and 5 are also on the inside of the parallel lines, and they're both on the left-hand side of the transversal. So angle 3 plus angle 5 also equals 180 degrees. Okay, let's now look at alternate interior and alternate exterior. Alternate interior angles are inside the parallel lines, but on opposite sides. Okay, so here is my little trick that I like to show for alternate interior and alternate exterior. And it's kind of weird. I don't have a really great way to help you remember, but if you draw the letter Z, so I'm going to use a yellow highlighter. I see a letter Z right here. Okay, I made the letter Z. And so watch what happens. Inside the parallel lines, but on opposite sides of the transversal, do you see how 3 is in the little crook of the top part of the Z and the 6 is in the little crook on the bottom part of the Z? So 3 and 6 are going to be congruent angles. So they're inside the Z. Angle 3 is congruent to angle 6. Alternate interior angles. Alternate interior, alternate interior. Okay. Alternate exterior angles. These are outside of the parallel lines on opposite sides. So 1 and 8. I'm sorry, is it 1 and 8? 2 and 7. Okay. So 1 and 8 and 2 and 7, both of them actually count as the alternate exterior angles. So 1 and 8 and 2 and 7. Angle 1 is congruent to angle 8, and angle 2 is congruent to angle 7, both of them. Okay. And so the other pair of alternate interior angles would happen if I drew my Z backwards. If I drew my Z backwards, I could also say that 4 and 5, if I flipped that Z around, they would be on the interior. So angle 4 is congruent to angle 5. Okay. And here's example 1. I'll zoom out a little bit. So we're going to do some vocabulary, which angles are linear pairs and which angles are vertical angles. And then we're going to find the measure of each angle. So my linear pairs are, let me go ahead and name each of these angles, okay? So this is going to be angle ACD, and this is angle DCE. And these are linear pairs. So ACD and CDE. Okay. Bring my mouse back over. Also, I've got ACD and this angle here also form a linear pair. So ACB ACB. Okay, and then there's two more pair of linear pairs. So ACB and this angle BCE. BCE. And then the last pair of vertical angles here, I'm squeezing them in, are this BCE and the CDE right here side by side. So BCE and CDE where I started. Okay. All right, which angles are vertical angles? Remember, vertical angles are opposite sides. So ACD and vertical angles are congruent to one another. So BCE. And also I've got these two. So CDE. I know this is just like a lot of letters. And then this angle is ACB. So we've identified all the linear pairs and all the vertical angles. Now we're about to find the measure of each angle, okay? We're going to do this using our definition of vertical angles. Vertical angles tell me that these two are congruent to one another. So here's what I'll do. Congruent means that they're equal. So take x plus 28 and set that equal to 2x plus 16. And now I need to solve for x. Okay, solve for x. So I'm going to subtract this x over, and I'm going to subtract this 16. 28 minus 16 is 12. Okay, so I found the value of x. So here's what I'm going to do. I'm going to plug in x to one of the two angles. It doesn't matter which one you plug it into. I'm going to choose the angle where I have to do less work, okay? So 12 plus 28 equals 40 degrees. 40 degrees. Okay? 40 degrees. So this side is, oops, I haven't used that pen before. I guess I'll use pink. Okay, that side is 40 degrees, which means that this side is also 40 degrees. Okay, if these two are 40, then what is going to be the measure of this angle? So to find this, because this is a linear pair, linear pairs add up to equal 180 degrees. So here I'm going to do 180, subtract this 40, and I get 140 degrees. And so this is a vertical angle here, so this is also 140 degrees. Okay, and so these are all my angle measures. And if you add them up, because this is a full-on circle, this should equal 360 degrees. Okay. Let's take a look at example number 2. Find all the pairs of each type of angle. So this again is just practicing the vocabulary. So corresponding angles, let me try to color code here. corresponding angles are on the same side of a transversal. So this horizontal line is my transversal. This is line L. This is line T. But wait a minute. These are not parallel lines, are they? It doesn't tell me that they are. Okay, but we can still identify the positions. So 1 and 5 are corresponding. 4 and 8 are corresponding. Now I'm going to move to the right side of the transversal. 2 and 6. And then 3 and 7. Okay, so I've got 4 sets of corresponding angles. Let's do same side interior angles. So this looks a little weird, right? I said that you could draw a Z, and you still can. So here is, now it might even be, it'll look really weird. Okay, but here's my Z. It's like if a toddler was practicing drawing a Z, right? And they didn't know how to do it right. It comes out to be looking really weird. But once you draw this little Z, you can see that 3 is inside and 5 is inside that in the little crooks here. Okay. So 3 and 5. Whoops, I'm sorry. I wrote that in the wrong spot. These are alternate interior. 3 and 5, alternate interior. Okay. Also, 2 and 8. So they're inside these lines, but they're on opposite sides of the transversal. So 2 and 8. All right. Same side interior. Same side interior. You get a different color, I guess a darker blue. 3 and 8 are on the same side of the transversal, and they're both inside here. So 3 and 8. And then also on the other side, I have 2 and 5. 2 and 5. And now we're going to do our alternate exterior. So the angles on the outsides of everything, opposite sides of the transversal. So 4 and 6, 1 and 7. 4 and 6, 1 and 7. Okay, so this is really just another example where it's just a different position. The transversal is not as easy to see. It's just in a different position than our first example. Okay. Now for example 3. So we're going to use all of this vocabulary and we are going to find the angle measures for all 7 angles. Okay. Yes, ma'am.
Can you leave it on the last one you did too?
Yes,
Okay,
I sure will. Okay, so this is a little bit of bouncing around, okay, guys? I'm not going to go in order. I'm going to go with what I see first that requires the least amount of work. So I know that vertical angles are congruent. So angle 3 is vertical to that 128 degrees. So angle 3 equals 128 degrees. Okay. And now angle 5 is an alternate interior angle. It's on the opposite side of the transversal, but still inside the parallel lines. So angle 3 and angle 5 are congruent. 128. Okay. And now I see angle 5 is a vertical angle to angle 7. So that's also 128 degrees. So I found half my angles without doing any math. I just had to use the vocabulary. Okay. Now notice this too. They said corresponding angles are congruent. So I also could have said this is on the right side of the of the transversal, and it's on the top of line A, and this is the top of line B. So these would be corresponding angles, which are congruent. So it's another way to say angle 5 is still equal to 180 degrees. Now I'm going to have to do some math, not a lot. Somebody tell me, how do I figure out any of these other angle measures? What do I need to use?
Use angle on a straight line to find 2. And
Yes.
angle on a straight line to find 1. Angle on a straight line to find 4. All of them, yeah.
This is a linear pair, okay? So this equals 180 degrees. So angle 1 plus 128 equals 180. So what's 180 minus 128? $52. 52. Correct me if I'm wrong. Okay.
You're correct.
Okay. So now I know angle 1 is 152. I'm sorry. Whoops. Just 52. Okay, what do I know about angle 2? What are these called?
Yeah, vertically opposite. Sorry.
Vertical. Good. Vertical angles are congruent. Okay. What's the connection between angle 2 and angle 6? These angles are both on the right side of the transversal and on the bottom of line A, bottom of line B. These are corresponding angles. Okay, so angle 6 is also 52 degrees. And you could say angle 4 is a vertical angle to angle 6. So it is also 52 degrees. So you could use the vertical angle, or you could use corresponding angles again. Angle 1 and angle 4 are corresponding. Right, so we named a whole lot of angles using vocabulary and doing very, very little math. Okay, there's just one last piece that I need to show you. The converse of the corresponding angles theorem. Okay, the converse of that. So two lines, JO and KM, that are cut by a transversal, so this is the transversal, are parallel if I can say all these other things, okay? So, vertical angle theorem still holds. So 129, this one is 51. I don't need to prove anything about vertical angles here because I already know that it's true. And then I also don't need to prove anything about a linear pair because I know that's true and that doesn't have anything to do with this. So if I did the linear pair, what is 180 minus 51? right here?
129.
129. Is that going to prove that these angles that are corresponding are congruent? It sure will, right? And this would be another linear pair. So if I did 180 minus 129, I'm obviously going to get 51. Okay. So you can just go through here and show if I have these two corresponding angles. So 129, 129, 51 and 51. Then I can prove two alternate exterior. That's alternate interior, sorry. So, okay. So H, is this congruent? Well, I know vertical angles are congruent. So yes, these are. And then this angle to angle G, well, these are vertical angles. So yes, I got alternate interior covered. I need same side interior. 51 plus 129 is going to be equal to 51 plus 129. So those are good. And then my two alternate exterior angles. Well, 51 on the bottom left, 51 on the top right. Those are the same. And let's do the opposite. 129 on the top left, 129 on the bottom right. So check. So we can now say for sure that line OJ is parallel to line MK. All right, so that's the converse. Converse means it's like the reverse of the theorem. And that is our lesson for today. There is a quizzes assignment for practice for tonight. And then tomorrow, what we're going to do is spend a day reviewing the last two lessons, okay? Lesson 4 and lesson 5. And we're going to put all this information together and just do some practice problems. And then we'll take a quiz, okay? All right, so I'm going to say until next time. That's how I always finish my videos.